Hi, this is Alex from devstories.eu. Biopython Fundamentals, Episode 3 of 18. Your bioinformatics pipeline crashes midway through a run. You check the logs and realize a downstream script expected a FASTA file, but the upstream tool passed it a GenBank file. You now have to rewrite a parser from scratch just to extract the sequence data. Or you could use Bio.SeqIO. SeqIO is the standard Biopython module for sequence input and output. It handles the parsing of various biological file formats, so you do not have to write custom regular expressions or string manipulation functions. You provide the file path and the format string, and SeqIO handles the underlying file structure. When reading files, SeqIO gives you two distinct functions, and picking the wrong one is a common source of bugs. The first is read. You use the read function when you are absolutely certain your file contains exactly one sequence record. You pass it the file path and the format, like FASTA, and it returns a single sequence record object. If the file is empty, or if it contains two or more records, the read function will immediately raise an exception and stop your script. It is strictly for one-to-one mapping. More often, you deal with files containing many sequences. For this, you use the parse function. Unlike read, parse does not load everything into memory at once. Instead, it returns an iterator. This is the part that matters. An iterator yields one sequence record at a time, which keeps your memory footprint low even if you are processing massive multi-gigabyte genomic datasets. Consider a specific scenario. You have a GenBank file containing data for several orchid species. You want to extract these records, but you only care about sequences that are longer than 100 base pairs. Furthermore, the next tool in your pipeline requires FASTA format, not GenBank. You can handle the reading, filtering, and format conversion sequentially. First, you create an empty list to hold your filtered sequences. Next, you set up a loop using the parse function, pointing it to your ORCID GenBank file and specifying GenBank as the input format string. Inside the loop, the parse function hands you one sequence record object on each pass. You check the length of the sequence attached to that record. If the length is greater than 100, you append it to your list. If it is shorter, you simply ignore it and move to the next iteration. Now you have a list of valid, filtered records in memory. To save them, you use the write function. The write function requires three parameters: the sequence of records you want to save, the output file path, and the output format string. You pass in your filtered ORCID records, specify a new file name, and provide FASTA as the format string. That is all it takes. SeqIO automatically extracts the relevant identifiers and sequences from your GenBank records and formats them correctly as FASTA text. You do not need to manually build the header lines or format the sequence blocks. By pairing parse with write, you translate between file formats effortlessly. That's all for this one. Thanks for listening and keep building.